The octacube is a large, steel sculpture of a mathematical object, the 24-cell or octacube. Because a real 24-cell is four-dimensional, the artwork is actually a projection into the three-dimensional world. Octacube has very high intrinsic symmetry, which matches features in chemistry and physics. The sculpture was designed by Adrian Octacube, a mathematics professor at Pennsylvania State University. The university's machine shop spent over a year completing the intricate metal work. Octacube was funded by an alumna in memory of her husband, Kermit Anderson, who died in the September 11 attacks. The sculpture is displayed in the lobby of Penn State's Math Department. Artwork. Octacube metal skeleton is about 6 feet in all three dimensions. It is a complex arrangement of unpainted, tri-cornered flanges. The base is a 3-foot-high granite block with some engraving. The artwork was designed by Adrian Octacube, a Penn State mathematics professor. He supplied the specifications for the sculpture's 96 triangular pieces of stainless steel, and for their assembly. Fabrication was done by Penn State's machine shop, led by Jerry Anderson. The work took over a year, involving bending and welding as well as cutting. Discussing the construction, Octacube said, "It's very hard to make 12 steel sheets meet perfectly and conformally at each of the 23 vertices, with no trace of welding left. The people who built it are really world-class experts and perfectionists, artists in steel. Because of the reflective metal at different angles, the appearance is pleasantly strange. In some cases, the mirror-like surfaces create an illusion of transparency by showing reflections from unexpected sides of the structure." The sculpture's mathematician creator commented, "When I saw the actual sculpture, I had quite a shock. I never imagined the play of light on the surfaces. There are subtle optical effects that you can feel but can't quite put your finger on." Interpretation. Regular shapes. The Platonic solids are three-dimensional shapes with special, high symmetry. They are the next step up in dimension from the two-dimensional regular polygons. The 5 Platonic solids are the tetrahedron, cube, octahedron, dodecahedron, and icosahedron. They have been known since the time of the ancient Greeks and valued for their aesthetic appeal and philosophical, even mystical, import. In higher dimensions, the counterparts of the Platonic solids are the regular polytopes. These shapes were first described in the mid-19th century by a Swiss mathematician, Ludwig Schläfler. In 4 dimensions, there are 6 of them: the pentacharon, tesseract, hexadeciuron, octacube, hecatonicosacharon, and the hexacosachorin. The 24-cell consists of 24 octahedrons, joined in 4-dimensional space. The 24-cell's vertex figure is a cube. Despite its suggestive name, the octacube is not the 4D analog of either the octahedron or the cube. In fact, it is the only one of the 6 4D regular polytopes that lacks a corresponding Platonic solid. Projections. Octacube explains the conceptual challenge in working in the 4th dimension. Although mathematicians can work with the 4th dimension abstractly by adding a 4th coordinate to the 3 that we use to describe a point in space, a 4th spatial dimension is difficult to visualize. Although it is impossible to see or make 4-dimensional objects, it is possible to map them into lower dimensions to get some impressions of them. An analogy for converting the 4D 24-cell into its 3D sculpture is cartographic projection, where the surface of the 3D Earth is reduced to a flat 2D plane. This is done either with light, casting a shadow from the globe onto the map, or with some mathematical transformation. Many different types of map projection exist. The familiar rectangular Mercator, the circular mnemonic, and several others. All of them have limitations in that they show some features in a distorted manner. You can't flatten an orange peel without damaging it, but they are useful visual aids and convenient references. In the same manner that the exterior of the Earth is a 2D skin, the exterior of a 4-dimensional shape is a 3D space. However, just as the surface of Earth's globe cannot be mapped onto a plane without some distortions, neither can the exterior 3D shape of the 24-cell 4D hypershape. In the image on the right, a 24-cell is shown projected into space as a 3D object. Some of the distortions, curving edge lines. These are straight in 4 dimensions, but the projection into a lower dimension makes them appear to curve. It is necessary to use semi-transparent faces because of the complexity of the object, so the many boxes are seen. Only 23 cells are clearly seen. The 24th cell is the outside in. The whole exterior space around the object is seen in 3 dimensions. To map the 24-cell, Octacube uses a related projection which he calls windowed radial stereographic projection. As with the stereographic projection, there are curved lines shown in 3D space. Instead of using semi-transparent surfaces, windows are cut into the faces of the cells so that interior cells can be seen. Also, only 23 vertices are physically present. The 24th vertex occurs at infinity. Because of the projection, what one sees is the 8 legs and arms of the sculpture diverging outwards from the center of the 3D sculpture. Symmetry. The Octacube sculpture has very high symmetry. The stainless steel structure has the same amount of symmetry as a cube or an octahedron. The artwork can be visualized as related to a cube. The arms and legs of the structure extend to the corners. Imagining an octahedron is more difficult. It involves thinking of the faces of the visualized cube forming the corners of an octahedron. The cube and octahedron have the same amount in type of symmetry. Octahedral symmetry, called O in mathematical notation. Some, but not all, of the symmetry elements of 3 different 4-fold rotation axes, up, down, in, out and left, right as seen in the photograph. 4 different 3-fold rotation axes, 6 different 2-fold rotation axes, 9 mirror planes that bisect the visualized cube, 3 that cut it top, bottom, left, right and front, back. These mirrors represent its reflective dihedral subsymmetry D2H, order 8-6 that go along the diagonals of opposing faces of the visualized cube. These mirrors represent its reflective tetrahedral subsymmetry TD, order 24. Science illusions. Many molecules have the same symmetry as the Octacube sculpture. The organic molecule, cubane, is one example. The arms and legs of the sculpture are similar to the outward projecting hydrogen atoms. Sulfur hexafluoride also shares the same symmetry, although the resemblance is not as similar. The Octacube also shows parallels to concepts in theoretical physics. Creator Octacube researches mathematical aspects of quantum field theory. The subject has been described by a Fields Medal winner, Ed Witten, as the most difficult area in physics. Part of Octacube's work is to build theoretical, and even physical, models of the symmetry features in QFD. Octacube cites the relationship of the inner and outer halves of the structure as analogous to the relationship of spin 1/2 particles and spin 1 particles. Memorial. Octacube was commissioned and funded by Jill Anderson, a 1965 PSU math grad, in memory of her husband, Kermit, another 1965 math grad, who was killed in the 9/11 terrorist attacks. Summarizing the memorial, Anderson said, "I hope that the sculpture will encourage students, faculty, administrators, alumni, and friends to ponder and appreciate the wonderful world of mathematics. I also hope that all who view the sculpture will begin to grasp the sobering fact that everyone is vulnerable to something terrible happening to them, and that we all must learn to live one day at a time, making the very best of what has been given to us. It would be great if everyone who views the Octacube walks away with the feeling that being kind to others is a good way to live." Anderson also funded a math scholarship in Kermit's name. At the same time the sculpture project went forward. Reception. An article on the sculpture appeared in the March 2006 issue of Playboy. A more complete explanation of the sculpture, including how it came to be made, How its construction was funded and its role in mathematics and physics has been made available by Penn State. In addition, Octacube has provided his own commentary